Welcome, everybody, to today's webinar on project delivery of biogas RNG facilities. I'm Paul Green, and I run a biogas RNG advisory practice after about 30-year career in engineering and construction. We do these monthly webinars for educational purposes. And next one coming up will be September 17th. We're going to be talking about the Canadian Clean Fuel regulations. So I'm super pleased today to have with me Scott Hill from Swinnerton and Jim Miller from JRMA. We'll be talking about project delivery today. So thank you again for joining us. Looking forward to a very informative webinar. So here's the agenda. The slides will be available on my website, green-tech.com/events, as soon as this webinar is over. And you'll be getting an email tomorrow giving you instructions to get the full video recording. Let's get into it. So you want to build a biogas project and you're trying to sort out how to get going. A couple of main pivot points on choices to advance. Working with a vendor is a common first strategy, or working with a service provider. Vendors often are selected based on quals or price, and then the engineer and installers tends to come later. If you work with a service provider, typically you're selecting based on quals, reputation, relationship, and then the vendors would tend to come later. So there's really not any one technology company that provides the entire biogas facility in the US. So you do need to work collaboratively, both with vendors and your service providers. First phone call, either approach is viable. Strong vendors have their own equipment and technology based on their experience. The balance of plant, if you will, you need to be talking to them about piping and foundations, and there's gaps in the offering that need to be filled. So this concept of a scope delineation matrix, you've got to be closely watching. If you're starting with a project delivery firm, we're going to talk about the FEL 1 through 3 journey a lot today. And that's a very disciplined process that really is kind of the main topic of what we're talking about today, about getting through engineering, getting to EPC and design bid build kind of scenarios. And the technology vendors tend to be a secondary consideration and quite often would be competed. Some key terms today we're going to work on. One is to really work on vernacular and terminology. And as this industry is maturing, we're starting to pull from other industries like refining and the chemicals industries that have a very refined art of project delivery. So here's one that the industry is tending to use somewhat commonly: the class of a capital cost estimate. So class 5 being the roughest, least refined estimate, class 1 being the most refined estimate. Class 5, this table pulled together by the AACE, Association of Cost Estimating, again, 0 to 2% maturity. It's a concept design, and we're going to talk a little bit about what a factored estimate is. And then, class 1, you've got all the way up to potentially 100% design, and you've got detailed unit costs with detailed takeoffs. One of my goals that I'm trying to preach about these days is overall cost of projects, trying to figure out ways we as an industry can get our costs down. I just say, of late, we're seeing about $300 to $350 per MMBTU for food waste digester RNGs, and some of the returns are a little low these days. So I'm pressing it wherever I can to see increased standardization of equipment and piping runs. This would reduce development costs, reduce CapEx. We've seen as an industry what approaches tend to work and what don't. Less optionality analysis is something we could aspire to, right? Standard approaches. We're learning what works, we're learning what doesn't. Increased standardization, I think, is a worthy goal. Some other terminology. Here's one, the FEL. FEL for front end load, FEL 1 through 3. And we're going to talk a little about what's in each of these buckets: FEL 1, FEL 2, FEL 3. So as we communicate with each other, having lenders being able to communicate clearly with EPC companies and technology providers, let's all get on the same sheet of music here when somebody says, Well, what would it cost me for an FEL2 report? Well, we have to have a general understanding of what's in that. So when we say to ourselves, in 90 days, are we going to be at a class 4 or a class 3 estimate? We can agree with each other, what goes into each of those levels of estimate and how refined will they be. Sometimes there's free work available out there, but always when do we start ringing the register and needing to pay real engineering companies to do real work? So I'm always advocating any developer should be able to clearly articulate, what is my contracting methodology? Am I embarking on this project? Is this design build, progressive design build? Is this a design bid build job? Perhaps it's EPC, engineer, procure, construct as a lump sum, or maybe CM at risk. We're going to get into some of those terms a little later. Some of the inexperienced developers will tend to just kind of get into a project and feel their way around to what feels like a good strategy, not fully realizing that the industry is starting to mature around various project delivery terms. So a key goal I say here is we're trying to do things being very mindful of the budgets. So thinly capitalized developers are really looking to do as much work for as little money as possible. So us project delivery people, we're trying to be mindful of that. Sometimes you'll find the tech providers tend to do a little bit more work early on for less cost. Tends to be bigger developers with more financial bandwidth. They tend to even have some of their own efforts they can do in-house. I have a little kind of balance beam here that shows vendors and service providers on each end of the balance beam, where European technology providers, they can be very strict with their work scope. Any given provider has a slightly different offering when it comes to the process equipment, and just understanding what's in the package, what's out of the package is critical. And sometimes it can be a little bit random. And so drilling into the specifics of those packages can take a lot of effort. On the service providers, sometimes if you're leaning earlier on the service provider for help, they can do more competitive bidding equipment. They're a little more disciplined on engineering drawings, but all of that discipline comes at a cost. And so sometimes it's a little more expensive early on. It is human nature to try to get through the development process to FID at as modest as your cost as you can, but sometimes the costs do add up. The point here is get the right answers at the right time. Don't do too much work too early. Because what if the project doesn't go, right? What if the economics don't pencil? So here's this photograph. Here's a biogas system going up with a digester and some carbon beds and a bunch of piping. And you look at this, and so part of the project delivery questions would be, how are these soils? What are the best piping to use? Do I need 6 or 8 inch pipe? How many pipe supports? How tall are the carbon beds? How thick are the foundations? How tall is the digester, et cetera, et cetera. The point here being, getting to detail costs you money and it takes you time. If a project is a good one, you continue. If it's a stinker, you need to kind of abandon ship, and don't determine if a piece of pipe needs to be 6 inches or 8 inches too early on when maybe the project isn't going to make your go no-go analysis. This FEL 1 through 3 journey gives us some level of discipline by which we know when to start doing things like pipe sizing. And busy screen here. I'm not going to go through all of this, but the FEL 1, or a definition of a project budgetary estimate, you're doing some optionality analysis. You're playing with various approaches. You're determining the size of the plant. Is it 50,000? Is it 200,000 tons a year? You're doing some very rough drawings like block flow diagrams, just rough arrangement drawings. You're getting to this class 5 capital cost estimate, perhaps class 4. You're doing your operating costs. You're coming up with a schedule. You're just looking to see about client biases and specifications, equipment preferences, and you're thinking about process risk. Who am I going to look to provide schedule guarantees, price guarantees, and process guarantees? Once you get through the FEL1, comes FEL2, which gets you some more depth. You're starting to finish up your pilot trials. You've said to yourself, what is my project execution strategy? What am I going to compete out? What am I going to sole source? What subcontracts will be competitively bid? You've kind of finished your optionality analysis. You've settled on what equipment is going to be there. The kind of go no go decision on the project happens at the end of FEL2. You've said to yourself, okay, I've come up with some. This is the detail. This is what you would see in a common FEL2, first gen 3D model, and all these things here. The service providers have a standard approach to what comes into FEL2. Once you say to yourself, this project is going to go, I need to advance to FEL3, you can say to yourself, how am I going to contract with this? Am I going to go design, bid, build? Am I going to do EPC? This takes real dollars and it takes real time. So here's an example of just a typical thing that happens later in the project. This is called a line list. Here's a project that has 3-inch lines. It has a line number, material spec. Is it insulated? Yes, no. Is it heat trace? Yes, no. How thick is the wall of the pipe? Where do I find it on the P&ID? It's going from, in this case, the food waste digester to pumps. What's the operating pressure? What's the test pressure? What's the fluid in there? Oh, it's a liquid pipe. It's not a gas pipe. This clearly is not an early stage work product, right? You don't get this at FEL1. You get these line lists that are beautiful. It kind of tells you everything about every line in the drawing, but that's later. One term that gets bantied around is a factored estimate versus an estimate with takeoffs. So factored estimate are class 5 and 4, where you say to yourself, I'm going to take my equipment price and I'm going to add 50% to that for mechanical installation. I'm going to add 50% for electrical installation. And I'm going to use rules of thumb, metal buildings at $20 a foot, steel tanks at $1 a gallon. And I'm going to get myself to plus or minus 30, 40% accuracy. But later, you're going to actually determine your linear feet of pipe, your linear feet of cable. That's going to get you to your plus or minus 10% accuracy. 90% design comes, 100% design comes, and all of these have some pretty commonly agreed upon terms to it. I'm running thin on time to go through all these terms. We're going to hear some from Scott and Jim as time goes on, but there's a lot of buzzwords out there. Things like, we're going to hear more about what is contingency, what is a change order, inside battery limits, outside battery limits, OPCC, opinion of probable cost, ROM, a rough order of magnitude cost. So you're in for a good ride here for the rest of the webinar. Some fees based on complexity. FEL1s can be, sometimes you can get a freebie from somebody up to 100K. FEL2, you start spending some real money, and then FEL3 is you're well beyond FID. You've got your final approval because there's a lot of hardcore engineering at FEL3. So here's my contact. There's a sponsor of the webinar today, Golton's Green Technologies. They're a self-perform installer for mechanical, electrical, and business since 1940. A global company, grew up in the marine space, now doing RNG project installation, serving all 48 states, Houston and Miami based. Contact there is my friend Mike D'Angelo, and you can get his contact from the download. These projects Golton's installs is more modest in size, something below 3 to 5 million. So when you hear from Swinerton later, those are for big projects. Golton's is great for simple installation of modest size projects, something below 3 to 5 million. Here's a PSA gas upgrader with carbon beds that Golton's installed in Iowa. They do a beautiful job. With that, I am a wrap, and I'm going to hand over to Scott Hill from Swinerton. Scott's a project executive with Swinerton. He's from Arvada, Colorado. He's been in the business for 27 years, specializing in industrial construction, operational safety, quality control, design, build, and finance. operate and maintain. Swinnerton does concept design, project development, cost controls, and he's built a bunch of really interesting projects in this biogas arena. Scott, the floor is yours.
All right, I appreciate it, Paul. And thanks everybody for jumping on the call, and look forward to talking through this. Just as a whole, Swinnerton Energy, just a quick background. So Swinnerton Inc. At a glance is an employee-owned company, 4,400 employees plus. They were founded in 1888. There's 9 companies underneath Swinnerton Inc. and Swinnerton Energy being the newest company, which I'll go through here in a minute. We have 22 offices nationwide, strong EPC background, over 500 and counting from our solar up through our energy group. And we run in diverse market sectors. We have strong financial strength, and we have an entrepreneurial culture. Swinnerton Energy was recently formed back in 23, so we're roughly a year and a half old. We have about 75 employees, and we're based out of Arvada, Colorado. We have a strong EPC background, as right now currently 3 of the 4 projects we've completed have been EPC contracts. Diverse in the market, I would say, just on the feedstock fronts, we've done swine, we've done dairy, we've done municipal waste, wastewater specific, and getting ready to do poultry coming up. We have, again, lean on our Swinnerton Inc. group for our financial strength, and we have self-performed capabilities and design, build, finance, operate, maintain capabilities as well. And Paul alluded to it, kind of just talking in contract structures. Most common that we've found currently is an EPC with a lump sum. That seems to be preferred by financing. Some groups, I'd say 65% of our projects have been lump sum. The other ones have been a GMP. There's pros and cons to both sides of that. We think that obviously speed to market is a big deal. So when we're looking at developing FEL3 design, a lot of times we'll like to engage with owners at conceptual level and go under a pre-con agreement to develop that FEL. And then from there, we would then turn that into an EPC contract with a lump sum cost estimate or a GMP. Doing that, we like to do everything fully transparent. We think, again, the market cost is kind of the market cost, and then the negotiables are the indirect costs and the fees and the contingencies and the GCs. We've also seen projects where we've had some owners that they feel they've done enough of these projects where they'll advance further. And again, more design leads to more cost certainty. And that has a big appeal, but as Paul alluded to, that does require more upfront investment to get to that point. So the people that have more experience in these project developments, they have more historical data, they can make, and specifically if they're doing projects of similarity, then it becomes a lot more surety for them to advance design, and obviously you get to a better price. And by doing that, you're eliminating the white space where a lot of folks, where risk money would be put into bids to cover the parts and pieces that are unknown at the time of contract. Kind of talk just about it, an EPC with an IGMP and then a reconciliation. That would be a consideration of starting either at conceptual or at the 30% level, and then advancing under an initial GMP. And at that point, you could reconcile. And at IFC, you could either continue with the GMP contract, or you could flip it to lump sum and continue down the lump sum pathway. Some folks, as we talked about, they have enough history and they're comfortable in ordering their own equipment and progressing design themselves. Then at that point, there's a potential you would just come in under a GC or under design build type of agreement. Just talking about GMP, P kind of is a gross maximum price. And it's a cost type contract where the contractor is compensated for the actual costs incurred plus a fixed fee subject to a ceiling price. The contractor is responsible for cost overruns unless the GMP has been increased via change order. We'll talk about change orders a little bit down the road here. Savings resulting from cost underruns are returned to the owner, or they could be on a shared savings split with the EPC. We've seen both. These contracts work best with costs that can be estimated accurately and don't have large fluctuations. GMP contracts can also combine with other types of contracts. Again, it's cost plus contracts, which agreements reimburse contractors for expenses plus a determined amount of profit, usually a percentage of full contract price. Again, similar to lump sum, GMP contracts contain provisions to address unforeseen costs, so the guaranteed maximum may not be guaranteed. The changes are often needed when a client changes the design in the middle of the project. So we always have to be cognizant of the design. We always want to drive design to the dollar, especially when we've given a price and we're trying to hold that price. So it's very, important to have good design management, making sure we're feeding the vendor information to the designers, and vice versa. So everybody's working towards the same end goal, and we're not having to go back and redesign stuff for added costs and added time. The GMP does require owners to be savvy in the construction projects, and that's kind of where the flipping a GMP through design to a lump sum has potential cost savings for the owner and for us. It's less paperwork, less admin, less reconciliation monthly, and it's also can bring surety, as we have found out that some of the lenders, and again, going back, I would say most of our projects are lump sum. It seems to be most lenders, that's the way they want to go with these projects, the ones we've worked with. We do have some folks that are GMP, but again, there are more established groups that have more folks on the overhead to help control the costs through the GMP reconciliation period. One way to go on a lump sum contract would be potentially going lump sum and then going with a cost loaded schedule. And then all you're doing is reconciling the schedule monthly and the costs get fleshed out in that reconciliation. A lump sum contracts, sometimes called stipulated sum, is the most basic form of an agreement. It's stipulated will require the contractor to agree to provided services for a stipulated or fixed price. In a lump sum contractor, the owner essentially is assigned all the risk to the contractor, who in turn can be expected to ask for higher markup in order to take care for unforeseen contingencies. A contractor under a lump sum agreement will be responsible for the project execution and will provide its own means and methods to complete the work. The type of contract usually developed in estimating labor costs, material costs, and adding specific amount will cover the contractor's overhead, profit, and margin. If the actual cost of the labor and materials are higher than the estimate, the profit will be reduced. So basically, us at the EPC, we would eat the overruns if we weren't afforded relief through the prime contract. And if they were lower, then that would become profit to the EPC as well. But in the end, the cost to the owner is the same. EPC lump sum contract is suitable if the scope and schedule of the project are sufficiently defined and allow the contractor to fully estimate the project costs. Again, we've looked at these jobs and we've created a high level ROM at zero design, just one conceptual sheet. We've gone into full lump sum on what would be, you could call it an FEL 2.5. Again, there's a lot of white space. The overall cost of the job may be higher as if you get into design. Again, if you get into design, the cost could go up. Under a lump sum, that would be ours to eat that cost overrun on a lump sum versus a GMP. We'd have to reconcile on the way through it. So there is pros and cons to this. And again, the differences between lump sum, maximum price, the customer receives the savings. if the project doesn't reach the maximum price with a GMP. In some cases, the customer may share a portion, like we talked about. Additionally, a GMP is different from a lump sum contract. There is more accountability in the GMP contract. The contractor submits itemized invoices to the owner, allowing the owner to see the actual cost. Whereas a lump sum, again, we just submit an itemized SOV, schedule of values at the end of each month. Again, the plus to the savings is there is some more cost in review of the GMP and all the submissions of the invoices. So you have to kind of weigh both sides of that scale a little bit when you're looking at these. We have found that the higher percent of the market prefers the lump sum to the GMP, as they feel like that gives them more price certainty, which is kind of contrary to the definition. Getting these projects started, again, we have some owners that have come to us and they have basic feedstock information, and they rely on us to reach out to the technology vendors, take that, create a basis of design, and there we would then start developing a real high-level ROM. Some of these projects, we have developed our own spec book and our own design for plant layout, and that allows us to what we would hope to be a better defined cost even at a ROM, where we've eliminated a lot of the white space that's out there, down to 2-inch or bigger piping. We can pretty accurately cost those out. It's just still that balance of design that's left there. That is where the risk money lies. So you go through preliminary design and kind of your tech solution selection. Do you want an amine system? Do you want a membrane system? What kind of digesters do you need? What type of feedstock is coming in? Does there need to be grit removal? What kind of bedding requirements on the backside? What does the water need to be treated to? Just trying to figure out what that basis of design looks like. And at that point, it could be under a pre-construction agreement to design to move the design forward to, you could call an FEL2, an FEL3, FEL4. Again, kind of what we had talked about earlier is really how much money is the owner developers willing to risk to find out if the project is feasible or not. So being able to define the cost of the job with lesser design but have a more accurate number is kind of the ultimate goal for us. That gives us our market advantage going forward. Just kind of our preparation of working through the pre-con, developing the design to get to where we can execute either the EPC or continue pre-con to advanced design to get to a HAZOP and a permitted set of drawings, and then get under construction with startup and commissioning. It's kind of like we were talking about, is there's a prime area to where costs, changes in design have minimum cost impacts. So you can see it's kind of in that conceptual range into the middle of design here, where it's the optimum point in where you want to get all the changes vetted out and finalize the cost. As the project moves forward, the penalties go up and the opportunities to save money go down, because at that point you'd be looking at reworking design, if it's a GMP, going back and reconcile the GMP or the lump sum or the change order. And you'd also be looking at time, which is critical to these projects. As always, there's a requirement on the overall time of the project, as well as what that does to the GC costs of the project. Value added opportunities kind of through the different design models. Design, bid, build gives you the most certainty at contract time, but it also is the longest overall duration. As you're designing it, then you're reconciling, then you're ordering equipment, getting permits going. All that time is added to the overall length of the project. Construction management at risk. you can see under the procurement, you're kind of going through it and then getting design going. And then obviously you're reconciling or you're bidding out the packages and then getting started on the construction. Progressive design build, this is the model that we typically follow. And under a progressive design build, we would look at this as, again, what our preferred method is we come in and conceptual design. That allows us and the owner to sit down as a group, partner up, make the technology selections, advanced design. Then when we get to whatever level of either cost that the owner is willing to spend to get to an EPC, or we set, call it an FEL3, and we define the deliverables of that FEL that make it so we can get the most accurate estimate out of that, versus sometimes owners go out and they'll get an FEL that's done by a vendor, and that sometimes doesn't specifically spell out really what we're looking for to get cost certainty out of it. So we really like the partnership. We like the transparency. Again, you're not going with one designer and then you hire an EPC that has another designer, and then you have to hand off that design from one to the other. All that takes time. That can add half year or more to the projects, versus under the progressive design build and the pre-con, you're seamlessly going with the same group. And again, it comes down to, that comfort level with that EPC, with that design group, with your technology vendors, that the transparency's there, the open book's there. In the end, the cost of the market is the cost of the market. The real negotiation piece is just in the contingency, in the fee of the job, which we'll get to here, and review of a cost estimate. And at that point, you're creating design packages. You can call it a 30, 60, 90 or A, B, C, and D package that you're going to go out and get permitted on. And typically what we want to do is develop design to a point where we know as a construction group we can't outrun that design and end up in a delay. And we also want to make sure that it's ahead of the permitting process. But that allows us to start, if we start design, we think we can start the project, in that 4 to 6 month realm, depending on complexity of project, after NTP, versus waiting to get to a 90% set of drawings. And then as each package goes out, we internally reconcile that either under the GMP or again under the lump sum. Of the three, I would say this is going to be your best speed to market, and this would be your best cost certainty. So you have to kind of weigh out, what's my lost revenue for the duration of the job being longer, versus paying a little bit more risk money to get the job moving forward at a quicker rate. On a typical estimating, these are some of the line items we'll come up with: general requirements, all the typical spec sections of a project. And then we get down into the electrical, the earthwork, and the real meat and potatoes of the job is typically in the process equipment. I would say as a whole, these projects, we see them balance out as 50-50 equipment, labor, materials, or 60-40 equipment, labor, materials, where equipment typically on the higher side of it. So the real costs end up being in electrical, they end up being in process mechanical, and then obviously in the purchase of the equipment itself. Then you have basically all your direct costs before permit and fees, and then we'd have design engineering costs. They can run really anywhere from 4 to 10%, really depends on overall cost of the project. If the overall cost of the project goes higher, that percentage will go lower. Just like anything, there's cost efficiency and scalability. General requirements fall within 0.5%, building fees somewhere in that realm. SDI, that's insurance, usually 1.15 of the direct costs. General conditions, they can be anywhere from 6 to 9 to 10%. Again, really depends on size of project, complexity of project. $100 million job can be simpler than a $50 million job, and it may take more staff to do the 50. But again, it's just kind of working through that. That's that kind of open book. We sit down with the owners, we show them the staffing plan, make them understand what the cost is built around. And then we get down into the indirects. So there's GL, general liability, there's builder's risk, bonding. There can be escalation in them. Again, the contingency, that's always a hot topic. Who's carrying what contingency in what bucket, how much owner contingency there is, how much design and contractor contingency. And a lot of that really comes down to what the lenders require. Some lenders require 10% or more. Again, it's just kind of working through that piece of it, and then ultimately fee. And fee, really, there's typically a minimum fee on the projects as the EPC. We have a lot of risk in those, so obviously the fees is higher than an atypical job. And then obviously fee also is factored around risks of damages per the prime, LDs, any kind of asserted damages that seem to be, where the market is, and anything higher than the market, or what we determine on the risk factor when we do our risk analysis on the project. This is kind of a quick breakdown of a project we did. Again, you can see that the equipment makes up a large percentage of the project, with all the other items falling in there. And so 75–80% of the project is indirect costs. The other 20 is through the final hard costs and any indirect costs. Change orders, again, the EPC change orders amendment or addendum to the construction contract and the scope of work. Change orders can be initiated by either the owner or the contractor and can be used to increase the scope of the project, provide additional revenue. However, they can also create challenges for the contractor, such as having complete change-related work being negotiating. So again, most contracts are set up that the work always continues while the change orders are negotiated. It's really critical to stay up on your cost management and your change management and present changes as per the contract requirements. It's really hard to go back and start hashing through stuff if you let too much time go by. So it's always preferred to make sure you set the limits of your prime contract around that of reconciling monthly for any known changes out there. And these are kind of some of the other items. And again, a lot of EPC contracts are set up where there's no cost relief, only time relief. So again, just through the negotiation process, just understanding what the prime contract allows you in the change order process, and also, as an owner, how is it protecting you? And just on a schedule front, on an early one, we typically have our milestones, our pre-construction, understanding the contracting piece, the project design, getting commitments done, the submittal procurement process. Equipment procurement is a huge piece of this. You got to know when it's coming, so you know when to get it installed. And obviously construction and closeout commissioning, that includes startup commissioning, which is a huge piece of the puzzle, as well as final closeout documentation. That brings me to the end of mine.
Nice.
And my contact information, Scott Hill, Project Executive, Swinnerton Energy, Inc. Again, we're in Colorado, and you can find all this information on LinkedIn or on the handouts Paul's going to get back, right?
Thanks, Scott. Yeah, the presentations are actually up on my website as we speak. So thank you, Scott. Appreciate it. Great presentation. Okay, so we're on to Jim Miller. So Jim is a recognized industry leader in the design of high solids anaerobic digestion facilities in the U.S. His quals include project principal on more than 100 solid waste projects beginning in 1985. He brings a wealth of expertise in designing facilities to maximize functionality and efficiency in order to minimize costs. He was the engineer of record for exciting projects like the Monterey Regional Waste System in Marina, the ZWE project in San Jose, the CR&R project in Paris, California, some of our industry's biggest and best. Jim was the engineer of record. So it's a thrill to have you here with us. Jim, the floor is yours.
Thank you. So hello, everyone. I'm Jim Miller. Thank you, Paul, by the way. So Jeremy, let me do this. Jeremy is an architectural engineering services firm. We were founded in 1982, current staff of 75. Our expertise is in process facility design. Paul mentioned solid waste, a long background in that, and 14 years in the design of AD and biogas facilities. And then our specialty is balance of plant and process integration. I'll explain that a little more as we go forward. We have 6 locations. You can see on the screen here, our headquarters is in Brea, California. These are some of the projects we've done. Paul mentioned ZWDC. They go by Green Waste Renewable Energy now. But we were engineer of record on these projects. These are all high solids. We also do a lot of work in the wet digester arena, as well as food waste pre-processing. So my presentation is going to be about my own experience and observations, 42 years of doing industrial facilities and 14 in the biogas space, and some of the advice that I give to my clients. This is a flow diagram of the type of facility that I typically work in. Coming from the solid waste world, a lot of our projects are involved with the actual processing of solid waste. So we're dealing with incoming organics, which may be food waste or yard waste or even mixed waste from the collected waste stream. We usually, a lot of our facilities also bring in liquids, maybe fog. And the focus is typically on the anaerobic digester. What kind of digester are we going to have? Whose technology? All that sort of stuff. But for these systems, there's a number of different unit processes, all of which are important. It could be vital, could be big cost implications one way or the other. And one particular is receiving and pre-processing. One thing to remember about this, and Scott alluded to it too, these are all different technologies provided by different technology vendors who basically come to this space from different angles and don't always know how to work together. And for these systems to work, there's a lot of interconnectivity involved. There's conveyors and piping and conduit and controls and all that sort of stuff. That's what process integration is all about, making all these things work together, because at the end of the day, what you want is a singular system, an integrated system. You don't want a bunch of different technologies there. You want something that all flows and works together. And then to make things even a little more complicated, there's the non-process elements. There's buildings that some of these unit processes have to go inside. There's a site that it has to fit on. So that brings in grading and drainage and stormwater and also things like zoning requirements and all that stuff. So all that goes into making one of these facilities work. So with that, I want to talk a little bit about project delivery from a designer's standpoint. Risk and cost variation. So when you're first starting a project, you're first thinking about it, there's a big risk and cost variation potential. You don't even know what it's going to cost yet. So that's somewhere nearly 100%. Then as you then design basically starts at zero, works its way up to where you start construction, and then there's an admin role for the rest of the project. And the cost you spend, and this is consistent with what Scott was saying earlier, through these early phases of the project, you're not really spending much cost in terms of comparison to your total capex. So when you put this in a scale like this, all these FELs, I found out when we were preparing for this that Paul and I had a very different opinion of what was FEL2 versus FEL3. And so I think my advice is let's don't worry about that for a moment and talk about what has to happen you're conceiving a project. You're going to start talking about throughput. I want a project to process 100,000 tons a year. I want a certain type of technology. I want to put it on my transfer station site, things like that. And at that point, this is just you thinking probably. Then you start to have to put detail to this, sizing and vendor input. Maybe you contact vendors, as Scott alluded to. You preliminary engineering data. Maybe you go out and get a geotech to just be sure the site is viable. Permitting, you will want to make sure that you can even build this in the location you have, and certainly schedule when you want this up and running. So all of these things you determine, and typically at this point there's what's called an ROM, or Class 5 budget, that you may put together just by saying, it costs X dollars per ton to build a facility like this, something like that. But this is typically where you hire a consultant or some outside presence. Maybe you bring in your EPC at this point. Then the first thing, once you get these, let's say, professionals on board, you're going to do things like a preliminary general arrangement, process flow diagram, maybe a mass and energy balance, material specs, and things like that start to bring more definition to the project, turns it into something you can now start to count, tons, square footages. And typically you revise your budget. Now maybe you get down to a Class 3 or 4 budget, something like that. So assuming the project's still a go, now it's typical in my experience that the next thing you do, you start to get your general arrangements more defined. You do a P&ID. You start to develop your contracting strategy if you haven't done that already. You get to where you're identifying equipment, maybe even to the point where it's, like I said, ready to order. So you can start to get real data and information from the equipment vendors. And then you do what I'm calling schematic balance of plant design. You lay out your site, you lay out your buildings, you check your utilities. So again, now you can start counting lineal feet and square footage to refine these numbers. And this is where, in my experience, you get to a probable cost estimate. So let's say a Class 2 estimate, and that's, in my experience, somewhere here is about where you now make your FID, your decision to go forward based on financing. So I want to talk about how this may be a little different with the different options. First of all, design, bid, build. So in design, bid, build, all design is done by the owner's consultant. The owner developer hires a engineering firm. They put out a set of full, complete plans that are ready for field construction. They go out and get competitive bids. And in that scenario, the contractor assumes no risk for design or operational performance. That could be a negative. Where it's a positive is where this has been done. If you've built 20 facilities and this is the 21st and they're all alike, then you're okay with that. If you're doing this for the first time ever, and maybe it involves a novel, some kind of process, I wouldn't advise this type of procurement. In this case, also, vendors and subcontractors are generally selected on low bid, which can sometimes lead to trouble. And I said it's a good model for repetitive design. Another is EPC or design build with an FEL3. And in this scenario, basically, the design up to FEL3 is by the owner's consultant. And I hate to even use that because Paul and I, again, didn't fully agree. This may be FEL2, but the point is that you reached a point where you believe you've got enough information on paper that a competent design build or EPC can bid it and complete the project. And then the rest of the design is by the contractor team. In this situation, the contractor EPC does assume a lot of the design risk, maybe all of it. But this does lead to a longer design duration, as Scott said, because this isn't a neat handoff. the new design team has to go back and learn all the thinking that went into what's on paper. And this comes after bidding and negotiation for this. So this whole process can drop a project. Scott said 6 months, and I think that's certainly probably a minimum. So that's something to think about when you're trying to get to market. This is does possibly lead to an earlier construction start, compared to design build bid. High potential for change orders. I've seen this go where the design team, now they're looking at it to minimize costs to the contractor, and the owner's thinking they're getting something else. I've seen that lead to problems. EPC with early engagement, Scott mentioned this, and I heartily endorse anything that gets the contractor to the table and engaged early on. In this scenario, maybe the design by the owner's consultant is very preliminary, just enough to give some basic project definition. And then the EPC team or design build team comes in and takes it over from there. That now does basically put the EPC in the position to lead the design. There's less learning curve at this point because the design team's in earlier, better cost input during design, far less potential for change orders because the EPC is now bought into the project from day one. A lot of the design is based on their thinking and their input and their costs. And so there's just really nothing left, or very little left to lead to change orders. So it comes up a lot when I talk about early selection of a contractor, EPC. Well, we want to competitively bid everything, and, this just doesn't really work for us. But let me tell you, it does work for anybody. And here's how you do it. So you start with 3 to 5 candidates based on recommendations and referral. Go out and find jobs that are similar to what you want to do and find out who did them, or talk to people in the industry and get names. And then verify their qualifications. Maybe one of those is a ringer. It's somebody's brother-in-law or something, but you can check that out. And then go meet with them. Go to their facility, meet with them, make sure they're the real deal. That's important. Getting to know them and their operations. And then you obtain proposals for fees and general conditions and contingencies, all that soft stuff that Scott was talking about. In my experience, those proposals, those numbers should be really close, but if they're not, that'll tell you something as well. But so now you've got, let's say, competitive bids for the soft part of the project, which is at whatever 15 or 20%. And assuming that there's still more than one candidate and everything else is pretty equal, pick the one you like the best, because these facilities take a long time from the initial conception till you're finally commissioned and it's your facility. You got to live with these people a long time. You better get one you like and you can work with. And then competitively bid all subcontractors. So once this entity is in place, they're going to go out to the subcontractor and supplier world, and they're going to bid everything out. They're going to put everything on the table. You're going to participate in the decision-making, full transparency. So you can be confident you're getting the best cost and the best participation. So last thing here, risk and mitigations. Risk is always a big topic, always takes a lot of scrutiny and all that. But I'm here to tell you that the risks are really pretty straightforward. The first one is construction related. The project doesn't get built or it costs too much. Simple as that. So what's a mitigation for that? One is appropriate procurement method. Don't low bid a really complex project if you haven't done this before, if you don't have the resources to manage it, if you don't have the upfront design to be confident of it. Be sure your procurement method matches the situation. Second, early involvement by the builder. I heartily endorse that. And I guarantee you would too if you've ever done it. And then qualified design and construction teams. There's no replacement for having people on the job that know what they're doing, that have done it before. It's not about intelligence. It's not about competence. It's about knowing this kind of work. I can't overemphasize that. So the other risk is it doesn't work. You get it built and it just doesn't work. And believe me, that's happened. History's full of that. And so what do you do with that? So one is proper feedstock analysis. And this may sound simple, but it's not. I can't tell you how many times I've gotten involved in projects where the developer or even the design team has very little concept about what's coming in the door, what they're going to process. Hugely important, and I think many times overlooked. So thorough FEL process, whatever you want to call FEL 1, 2, 3, 4, whatever. Make sure that you do that properly up front with the right people at the table and involved. Appropriate technologies and system, and I use the term appropriate because a lot of people out there are trying to sell a lot of things that have never been used the way they claim. So make sure you're using the right thing for the right job. And then improving. Make sure that you don't just take somebody's word for it or you Google it, find it online. Make sure that it's proven for what you're doing. Qualified design team, you probably heard me use that word qualified before. Can't overemphasize how important that is again. But then the other thing is you as the client, you, the owner, the developer, there's also no replacement for you getting into the weeds and understanding what you're doing here and not depending on third parties to deliver a successful project. That may sound simple and straightforward too, but yeah, again, history's full of situations where that didn't happen and it didn't end up well. So with that, it's been a pleasure. Whoops. This is me. And Paul, I'm ready to finish here.
Nice, Jim. Great job. Well done. So that's a wrap for today's webinar. Thank you for joining. And Jim, Scott, and I are here to help. You'll get an email tomorrow from me that gives you the link to download the slides, and the live recording will be prepared shortly. So don't hesitate to reach out. We're a resource. We've been around a little while and we're here to help. So thanks again, everybody, for joining. Hope you learned a bit, and catch you next time.